Alright guys, so this is our last section. It's going to be divided up into two videos. So this is the first video, and we're going to be looking at linear equations today, and then the next lesson will be linear inequalities. So again, this is just review for Math 1. So let's talk about a system of equations. So we can model many problems by a collection of linear equations called systems of equations. If you look up here, they were talking about digital TV sales corresponding to the decline in sales of DVD players. So we're talking about your streaming and your satellite and things like that versus having a DVD player and like renting movies. So here, this was considered the red line, and this was considered the blue line. So if you wanted to know when the digital TV sales overtook the DVD sales, DVD player sales, you could do that if you had an equation. Okay, so let's just move on. So the solution would be the intersection. Okay, if you're solving systems of equations. So a solution of a pair of linear equations is an ordered pair of numbers that satisfy both equations. Okay, so we've done kind of like this before. So if we plug in 5 and 3 in for x and y into both equations, they did that here. That makes them both true. So therefore, the ordered pair 5, 3 is where these two equations would meet if you would graph them. So you would get them in slope-intercept form and graph those, and they would intersect at 5, 3. Okay, so moving on to the next part. Again, we're moving on. Because the ordered pair 5, 3 makes both equations true, it is a solution for the system. Although 7, 2 makes the first equation true in the system, it does not make the second equation true. Therefore, it is not a solution for the system. Okay? It's only a solution for the first equation. If you want to see if it's a solution to both, it has to work in both. Okay? All right, so case 1. If you have two lines, there's only 3 things that can happen. They can intersect and have one solution. Okay? This point represents the solution. You could have parallel lines, lines that don't touch, and if they don't touch, they have no solutions. Or, we've talked about before, once you get y by itself and reduce it, it may turn out to be the same equation, so therefore it's the same line, so they have infinite number of solutions. So those are the only 3 things that can happen. All right, so how can we solve systems of equations? So the first way we can solve them is with the elimination method. So I'm just going to highlight the word elimination method, and we're just going to refresh our memories on how to do that. So what do we want to happen? Okay, we want a letter to cancel out, so multiply both rows by a number to get there. Okay, so we want a letter to cancel out. So we need one to be positive and one to be negative. So we need like a 2x and a negative 2x. We need like a 12y and a negative 12y. So if we look at this right here, they're already different signs, so we can make those y's go away. Now, what we can do is we can multiply this top row by 3 to turn that into 12, and multiply this bottom row by 2 to get that to be negative 12. And that way our y's will go away. But we have to multiply the whole row by that number. Okay, we can't just go multiplying one piece of that row. So this is going to become 9x plus 12y equals 30. All right, and this is going to be 10x minus 12y equals 8. Now, if we line these up like we're going to old school add them, these will go away. This will become 19x equals 38. So x will be 2. Then our last step will be then plug the found value into the original first equation. Now, you could plug it into the second one, but if I just tell you to do it into the first one, then you're not going, okay, which one works, which one doesn't? Just always plug it into the first, and then you don't have to worry about it. But yes, it would work in both. But use the original equation. Okay, so our first equation is 3x plus 4y equals 10. And the number we found was x equals 2. So we're going to plug the 2 in for x. Okay, so that gives me 6 plus 4y equals 10. And move this over. So we have 4y equals 4. We divide by 4, so y is 1. So the solution to this problem is x is 2, y is 1. So we write that like an ordered pair. So these two equations, if you were to graph them, would intersect at the point 2, 1. Okay? All right. Okay. Now, let's look at the next one. This one doesn't look too fun. So, yeah, that looks not nice. But if you look right here, one's a plus and one's a minus already. And if we just multiply this one by 2, they will cancel. So what I'm going to do is I'm going to multiply this top one by 2. And if you feel like you have to multiply both of them, you can say you're multiplying this one by 1. You don't really have to multiply it by anything. Okay, so if you're not confident in your skills, which you should be because we did a whole unit on fractions, this 2 is like 2 over 1, so those 2's cancel. So this is negative 3x, but you could use your calculator if necessary. Then 2 times y is 2y. Then here, this 2 reduces this 4 to a 2, so it's 5 halves, which is 2.5, if you're looking at a calculator. Okay, then when you multiply everything by 1 here, it becomes 3x minus 2y equals 1. So when you go to combine these, you'll look and you'll go, wait a minute, both my x's and y's cancel, which is okay if the two things equal. But in this case, they do not equal, so this is no solution. which means that these two equations, graphically speaking, are parallel lines. Okay? So we would say that this system is inconsistent because it has no solutions. All right, let's look at this one. Those of you that are not big fans of decimals, you might want a little bit of help with this one. So I'm going to multiply this one by 0.1, and I'm going to multiply this one by negative 0.2. So this one becomes 0.02x minus 0.01y equals 0.03. This one becomes negative 0.02x plus 0.01y equals negative 0.03. When you go to look at this, you're going to say, hey, wait, everything goes away. So we have 0 equals 0, which is a true statement. So we say that it has infinite number of solutions. Okay? And if it has infinite number of solutions, then we say it's dependent because it's the same line. Okay? It's the same line. So they're like laying on top of each other. So if I were to get y by itself here, it would turn out to be the same equation. Okay? Moving on. So the next thing we're going to look at is the substitution method. Okay, if you think back to Math 1, you might remember this. So step 1, we're going to solve one of the equations either for y, x or y, depending on which is easier. Okay, and I'm going to write some little helpful notes over here to the side. So this little helpful note is pick one equation to get letter by itself. Okay, so if we look at this problem right here, one of the letters looks like it would be easy to get by itself. And it's going to be in the first equation. And we're going to get the x by itself. So step 1, we have x minus 2y equals negative 7. So we're going to get the x by itself, and we get x equals 2y because it becomes positive, and this should be a minus 7. Okay. Now, step 2, this is where the substitution part comes in. Next, back substitute this expression in the first equation of this into the first equation. Okay, so what we're going to do, we're not using the one that they're doing, we're doing our own over here, is you plug in that info for that letter in the other equation and solve. Okay? So what that means is, step 2, we're going to take what this equals and plug it into the other equation for x, because it says x is this. So we're going to do 3 times 2y minus 7 plus 5y equals 12. So this is 6y minus 21 plus 5y equals 12. So this is 11y minus 21 equals 12. So we move the 21 over, so this is 11y equals 33. Then we divide by 11, so y equals 3. Now back substitute in, and we're going to put, just remember I told you if I make you lock into one equation, then it'll make it easier. In the first original equation, okay? So what we're going to do, this part's easy. So step 3, the first original equation was x minus 2y equals negative 7, and we know y equals 3. So we have x minus 2 times 3 equals negative 7. So x minus 6 equals negative 7. Add the 6 over, x is negative 1. So my ordered pair is negative 1, 3. Okay? And that's your first example. Now we're going to do this one. Now on this one, we could either get x or y by itself. It doesn't really matter. But I'm just going to get x by itself just because it comes first. So step 1, we have x plus y equals 6. We're going to move that y over. So x equals negative y plus 6. Now we're ready for step 2. We're going to take this and plug it in for x. So this is 2 times negative y plus 6 equals 8 minus 2y. So this is negative 2y plus 12 equals 8 minus 2y. Okay, we need to get our y's on the same side. So I'm going to move this y over here. So when I add 2y to negative 2y, they go away. And I get 12 equals 8. That is a false statement, so we're stuck. We can't go any further, so my answer here is no solution. All right, let's look at this one. If you look at these two equations, it's easier to get this y by itself than it is anything else. So we're going to work with this one. So step 1, we have 4y equals negative 2x plus 16. So we're going to divide both pieces here by 4, and we get y equals negative 1/2 x plus 4. Okay, so now we're going to plug this in for y. So step 2, we have 3x plus 6 times negative 1/2 x plus 4 equals 24. All right, so I have 3x, half of 6 is 3, and there's a negative there, so that's negative 3x. 6 times 4 is 24. If you look here, those go away, and I'm left with 24 equals 24. That is a true statement, so this one is infinite number of solutions. All right, and if you need to pause that to get that written down, feel free. All right, supply and demand. Okay, so the law of demand in economics states that as the price of an item increases, the consumer is less willing to purchase it. According to the law of supply, as the price of an item increases, the producer is willing to produce more of the item. Okay, on the other hand, so if the price is low, consumer demand increases. The price is low, the consumer demand increases. But because the producers are not willing to produce much, there will be a shortage of the product. On the other hand, if the price is high, producers will produce more of the product, but because consumers are not willing to pay the high prices, there is a surplus of the item. Okay? Eventually, the market for the item adjusts so that there will be a price at which the quantity demand and the quantity supplied are equal. This point is called the equilibrium point. So they have to find that sweet spot between what they're charging and the amount of product that they have. Okay, so they got to find that sweet spot where they're still making money, but they're not sitting with a bunch of product on hand. So Malik sells handcrafted turquoise, Native American jewelry at regional craft shows. At a price of $20 per necklace, he is willing to buy 30 necklaces from his supplier. However, at this price, his suppliers will only give him 9 necklaces. Okay, so let's look at what we have. So, let's talk about demand. And we'll also talk about supply. Okay, so the first thing is if there's $20, he wants 30. But his supplier says for $20, we're only going to give you 9 necklaces. Okay, however, if he pays $60 per necklace, he can only sell 15. So the demand is only 15. At this higher price, his suppliers, so at 60, his suppliers will sell him 29 necklaces. Assuming that the equations relating to the price to demand and supply are both linear, what should the price of the necklace be for the supply to equal the demand? So what's going to be their sweet spot that they can agree on? Okay, so what we're going to do is we're going to write 2 equations. We know how to write equations given 2 points. Okay, so we got to find our 2 equations. That's going to create our system, and then we'll be able to solve it to find our our sweet spot. Okay, so remember, we're going to find our slope first. So we're going to do 29 minus 9 over 60 minus 20. And that's 20 over 40, which is 0.5. Okay. Step 2, we need to find our equation. So our slope is 0.5. And the order pair we always use our first one. And we're going to write an equation using our y equals mx plus b. Okay? So we know y is 9, our m is 0.5, our x is 20, plus b. So we have 90, half of 20 is 10, plus b. So when we move the 10 over, our b is -1. So our equation is going to be y equals 0.5x minus 1. But we want it in standard form. Remember, in standard form, you want your x over here with your y. So we move that over. That's going to be -0.5x plus y equals -1. Now, so that's my supply equation. Now we're going to do our demand equation. So first thing we're going to do is our slope. So that's going to be 15 minus 30 over 60 minus 20. So that's going to be -15 over 40, which is -0.375. So step 2, we know our slope is -0.375. Order pair is 20, 30. And we're using the equation y equals mx plus b. Okay, so we have 30 equals -0.375 times 20 plus b. So this is 30 equals -7.5 plus b. We move this over because we multiplied that, and that's what you get. So this gives me 37.5 equals b. So our equation is y equals -0.375x plus 37.5. So now we want it in standard form. So this is 0.375x plus y equals 37.5. All right. So now we're going to write our two equations down. Let's see. So our first equation is -0.5x plus y equals -1. And this one's 0.375x plus y equals 37.5. Okay, this is my system. I'm going to write here system. All right, so we look here, we're trying to get a letter to cancel out. So if I multiply this one by -1. And don't do anything to this one. And if you want to put a 1 there to show that you did something, you can do that. That's -0.375 minus y equals -37.5. Okay, so when I add those two together, let's see. So those are going to cancel. That's going to be -0.875x equals -38.5. Okay, so now we divide. X is 44. All right, so that's step 1. Step 2, we're going to take the first equation and the number we found to find the other. So -0.5 times 44 plus y equals -1. So this will be -22 plus y equals -1. We move this over, so y is 21. So the magic point is 44.21. So what this means is sell necklaces for $44 and get 21 necklaces. Okay, and that's what the graph would show as well, down here at the bottom. Okay, that was a lot of writing, but not hard stuff. Okay, one more, and then we'll be done with this video for today. The last video will not be a long video at all. Okay, Aiden's Custom Woodworking Company builds cherry furniture. This week, they will manufacture only end tables and coffee tables. Okay, so these are two things we're making. An end table requires 6 board feet, and a coffee table requires 8 board feet. Okay, and they have 1,200 board feet. Okay, then takes 2 hours of labor to make an end table and 4 hours of labor to make a coffee table. And they have 480 hours of labor to do this. Okay? You're wanting to use all your labor and all your board. Okay? So we got to make an equation out of the purple. So we're going to use E for end tables and C for coffee tables. So let's make our first equation dealing with materials. So end table 6 board feet, so 6E plus coffee table is 8. 8C equals 1,200 board feet. That's what we got. Okay, now let's go time. So we have 2 hours to make end tables and 4 hours to make coffee tables. And our hours have to total up to 480. Now we just need to solve this. Okay, so let's look. We could do this and multiply this bottom row by, we can multiply it by -3 and make the e's cancel, or multiply this one by -2. -2 is a smaller number, so let's do that. So this would be -4e minus 8c, and 480 doubled, it's -1440. Okay, I think that doesn't look right. Hang on 1 second. Oh, I used the wrong numbers. So 480 times 2 and multiply it times 3. That's 960. Sorry about that. -960. Then this one stays 6e plus 8c equals 1200. Okay, so when we do this, 8c's cancel. This becomes a 2e. 1200 minus 960 is 240. We divide by 2. That means we have 120 end tables. So now we need to know how many coffee tables we have. Okay, so we do 6e plus 8c. So this is step 1. Here's step 2. Equals 1200. And e is 120. So 6 times 120 plus 8c is 1200. 120 times 6 is 720. 1200 minus 720 is 480. Then so we're moving that over there. Now we're doing this. And that should be 60 coffee tables. So we made 120 end tables and 60 coffee tables. And this is something you really could use in a business to maximize your time and your materials. Okay? If you have any questions, please let me know. Have a great day.